present, we can take it now. Otherwise, then what? You can still email me. Surely you know my email address. And I think I've even written my phone number somewhere in one of the platforms. So what I'm trying to say is, even after this session, if you still have any question, you can just simply, send it to me. Then definitely I will answer you. I will respond. That is my duty. I must. Otherwise, I must be fired. Ne? That's right. Any question before we finish this year? If nothing, then let us look at, as I've said, that will be the last topic. That is using matrices to solve system of linear equations. Now, this is basically simultaneous equations as we know it from secondary. Now, but then conceptually, what do we mean by simultaneous equation? Remember, if you are solving, what is happening here? Can you still hear me?
Yes.
Yes, sir.
Something just happened on my side. All of a sudden, I was seeing some platforms here and that I was saying, what is happening? Now, remember, when they say solve, whatever simultaneously, let's say you have got two equations, it will be two equations, two unknowns. It will be equation number one, equation number two, then unknowns, it will be x and y. Then at the end, say you have got x equal to 3 and y equal to minus 3. Now we know this is a point. It means you found this point. Then it means that is the graphs of those equations. They intersect at this point. The graphs, if you have to draw the graph of those two equations, because it's equation number one and equation number two, then they will cross each other. The graphs will cross each other at this point, 2 and minus 3. Therefore, to solve two equations simultaneously, therefore, basically it can be what? Two approaches. You draw their graphs, then from there, you see where they cross each other, they intersect each other. Or it can be algebraically. Algebraically, we also have two approaches, two methods there. You can either use what? The substitution, or you can use the elimination. The substitution, that is where you take one equation and you make one of the variables the subject of the equation. You isolate x, then on the right side it will be y, then you call it that equation number 3, then you go and substitute that in the unused equation, then you will get one equation with one unknown. Then from there, you will solve that one unknown, because it's one equation, one unknown. You get its numerical value, then you go back to the unused equation, then you replace, then you get the other, it will either be x or y. Now, last year, I was told that you also did the same thing. That is simultaneous equation, but using what is called Cramer's rule. And in Cramer's rule, one of the first thing in Cramer's rule, remember Cramer's rule is using the determinants. Therefore, but before that, before even the determinant, what do? You take your linear system, you write it in standard form. What we mean by in standard form, we mean what? All the terms containing x, they must be in the same vertical line. All the terms containing y, they must be in the same vertical line. All the terms containing z in the same vertical line, so on and so forth. And all the constants on one side. Then from there, what you do thereafter with Cramer's rule? Then you because the unknowns, they will be on one side. Then you construct a matrix using the unknowns. That is what we call the coefficient matrix. Let's say you have got this. Let's say we have got this. We have got something like this, say X and Y. Say you have got X plus, let me just write this one, say 2Y here equal to 3. Then you call it equation number 1, obviously. Then we have got what? Say X here, then minus 3Y equal to 4. Then you call it equation number 2. The question is this in standard form? If you look at it, X is the first term, even here, X is the first term. Y is the second term, Y is the second term, meaning the X are in vertical line, the Y's are in vertical line. Then you have got the constants here alone on the other side. Therefore, your linear system is in standard form. Then from there, what do? You then, Cramer's rule. Then you form what is called the coefficient matrix. Coefficient matrix. Then you say the coefficient matrix, you can call it any name, A or B or whatever capital. Then you write only the numerical coefficients of the first equation. We know there is 1 here, then you write 1 here. Then there is 2 here, then you write 2 here. These are the numerical coefficients of your equation number 1. Then from there, what about the numerical coefficient of equation number 2? That is 1 here, you write it here. Then minus 3 here, you write it here. Then this is what is called a coefficient matrix. Then from there, from here, you must now find what is the determinant. So what is the determinant of this? It will simply be minus 3 minus 2, which is minus 5. And because the determinant is not 0, therefore, it has got a solution in this. It has a solution using Cramer's rule. Or with this one using Cramer's rule, we normally denote it by D. There from there, what will be dx then? Using Cramer's rule. You simply take this, but replace what? The numerical coefficient of x by the constants on the right side is dx. Meaning you still take d, which is the determinant, then you replace the numerical coefficient of x by the constants on the right side. Then it will be the numerical coefficient of x is 1. Then 1 here, it will now be replaced by 3. Then from there, you keep 2. Equation number 2, the numerical coefficient of x is still 1. Then you replace it by 4. Then from there, it will be minus 3. Then you find what? The determinant of this, which will simply be minus 9 minus 8 minus 9 minus 8 is minus 17. Therefore, what is x then? Finally, it will not be what? It will not be dx over d. That is why we're saying the d must not be 0. If d is 0, then this doesn't have a solution, meaning these two, they don't intersect. Equation number 1 and equation number 2, that is the graph of equation number 1 and equation number 2, they will never cross each other. So from there, you then substitute. What is dx? It's minus 17. And what is x? What is d? D is minus 5, using Cramer's rule. There from there, you can still go on and find what? And find the y. The y, it will be the same story. Here you will now be dy, meaning you come here to d. Now you replace the numerical coefficient of y, which is 2 and minus 3, by the constants on the right side. Then you get dy. Then you get is determinant. There from there, dy, then y will now be dy divided by d, then you get the answer. That is Cramer's rule. But now, what about solving this using matrices? It goes more or less the same thing. You just have to combine it with what? With the matrices. That is the knowledge of matrices. What we do here is the following. Solving this, let's say solving the very same thing using matrices. Same story. What will be the starting point? The starting point is find the coefficient matrix like you did last year. What will be the coefficient matrix? The coefficient matrix here we call it A. It will just say A, the coefficient matrix. We know how to get it, but before, make sure that your linear system is in standard form. So this now it will be called the coefficient matrix. And then from there, still, then you find the determinant of A. If the determinant of A is 0, then we know this will never cross each other. So now we know it. It will be -3 minus 2 with -5. Therefore, it has a solution. Now, how to find a solution now? Using matrices. Using matrices now. Now, what you do here, or generally, here, if you look at this linear system, you can write it in matrix form. You can write it in matrix form. But what is happening now? I can't see you. Can you still hear me?
Yes.
But here I have, on my side, I have got what? A different. But what is happening? Because I've got some news this side. I can't see you. I'm seeing news here. I'm seeing Malema here. And I said, but what is happening here? Okay, you will tell me when you can hear me or see me. Now, look at it. This part, if you write it in matrix form, it will be this, still write the numerical coefficients, and this is the product of, that is X and Y. I'm uncomfortable because I can't see you, but what is happening? So this linear, the left side, it can be written in this product. Because what is the order of this? The order of this, we know it. That is the order of this one is 2 by 2. What about the order of this one? Is 2 rows. And how many columns? Therefore, because of this, therefore, the product exists. And what is that product? Then we are going to say 1 multiplied by X is X. 2 multiplied by Y is 2. Then it will now be 1 multiplied by X is 1, minus 3 multiplied by Y is minus 3. So the left side now is written as the product of these two matrices. Now, what about the right side? You can also write it in matrix form. Therefore, this linear system can be written using these matrices. You can either write like this algebraically, or you can use matrices. So what you do, as we have said, first make sure that it's in standard form. Then from there, now you write it using the matrices. Then from there, this now, like yesterday, we call it the coefficient matrix, which is A. Then from there, you find its determinant, which is this. Then if you look at this again, if you call it this A, this is A. If you call it this, maybe you call it what? You call it X. Then equal to that is capital X. What about it is? You can call it B. And now because we know this product exists, then the only thing that we need to check is whether that A is non-singular. Yes, it's non-singular. Then from there, meaning it has got an inverse. So therefore, if you multiply both sides by the inverse, then this by this, because it will exist, because the inverse and the matrix, they have got the same order. Therefore, the product will exist, irrespective of the order. Whether you say inverse A by A or A by inverse A, the answer will be the same. Then from there, now we know what is this. This will give you the identity matrix of the same order. This is of order 2 by 2. Therefore, these two, they will give you 1, 0, 0, 1. These two, if you multiply these two, they will give you this identity or matrix of order 2, which is just I. Then we just write I. Then you have got X. Then the right side is this. And the product will exist because this is 2 by 2. And what is B? B is 2 by 1. Therefore, this is 2 by 1. Therefore, the product will exist. And the order of the answer is going to be, let us call it C. It will not be what? It will be 2 by 1. It will be 2 by 1. If you multiply these two, it will exist and it will be 2 by 1. So, okay, now, coming back here. Now, because this is the identity matrix, multiplied by X is equal to this. And we know because it's an identity matrix, it will preserve X. If you multiply these two, they will give you X back. So we don't even have to mention this. Because at the end, it will just give us X back. And what is this X? X here is the matrix of the unknown. That is the matrix of the unknown, which will be small x and what small o. And then from there, what is this? Then it will be inverse this. And what is B? B we know is this. B we know is B we know is this. So therefore, the only task now, which I'm not sure whether we still need to call it task, is just to find the inverse this, which we did last week, just to find the inverse. This is A. Then find the inverse. We know it exists because the determinant is not 0. It exists. Then we just find the inverse. Then you multiply it by this. Therefore, if the answer here is 7, 8, if the answer is 7, 8, then it means we are saying this. Then it means we are saying this 2 by 1 matrix is equal to this 2 by 1 matrix. This column matrix is equal to this column matrix. And we've said two matrices will only be equal if and only if their respective elements are equal. Meaning, this X here, it must be equal to 7. That is, X is equal to 7. And this Y here, it must be equal to 8. Then we are done. That is in short, or in general, then we are done. We have solved this using matrices. So the only thing that we need now to do is what? Find the inverse of this coefficient matrix. And how do you find the inverse of coefficient matrix? And we know because this is 2 by 2, then it's very simple. We can just, with to find to find the not the coefficient matrix, because this is a coefficient matrix, the cofactor matrix, and from there find its transpose. So, but now this, because it's 2 by 2, therefore what will be the cofactor matrix? We know you swap this. If only if it is 2 by 2, you swap this. This one comes here, this one comes here, retaining their sign. Now, what about these elements on the secondary diagonal? They are also swapped. This one comes here, this one comes here, but with this one, we know the signs is will change. This one will come here, but it will be -2. No, -1. This one will come here, but it will be -2. But in general, let us just, do it the general way. Because now our next example, it will be a 3x3, which shortcut, where this shortcut is not applicable. Therefore, let us just use that long approach. First of all, remember, we must now find what? We must now find the what do you call it? The minor. So what is the minor of 1, 1? The minor of 1, 1, we know the first one refers to the row, meaning you must now cover the first row. The second number here refers to the column, meaning you cover the first column. Then you find the determinant of this. The determinant of this, it will just be 3. Then from there, it will not be what? M12, meaning the minor of the element in the first row, the second column. Meaning you still cover the first row, now you cover the second column. That is, you cover the second column. Therefore, it will not be the determinant of this one element 1, which is just 1. And they will be what? The elements in the first row. Now, what about now elements in the second row? It will be M1, meaning now you cover the second row, the first column. The second row is covered. Then the first column, therefore it will not be, we cover these two. Then we are now going to cover these two. So then we are left with only 2. And now what about M22? You cover both the second row and the second column, the second row and the second column. You are now left with 1. Therefore, you can now find what? Write what? The coefficient matrix. Not the coefficient matrix, man. The cofactor matrix. So what is a cofactor matrix? You can call it what? Let us call it C. Let me just write it here. Hopefully you can see it. The cofactor matrix, C. Let us write it here. Hopefully you can see it. So what will be the answer here? The cofactor matrix? We know it must not be what? The product of minor and the cosine, the factor sign. So we have said if the sum of this is even, then that's plus. So the sum of 1 and 1 is 2, which is even. Therefore, it will be just 3 multiplied by positive. Therefore, it will be 3. And what about this one?
Can I ask something, please?
Yes, ask.
Okay, that M11, you wrote it as 3, not -3.
Oh, cover this.
Yeah.
Thank you very much.
Okay,
-3 here, -3 here. Now, what about this? You sum this, is odd. Therefore, you are going to multiply this by negative. So the answer here will be minus. What about this? The sum here is odd. Therefore, you are going to multiply by this by negative. It is -2. You sum these two, the answer is even. You are going to multiply this by positive. Therefore, the answer it will just be this. And that's it. Then from there, what next now? But did it change? What happened here? That's perfect. That's perfect. Then from there, you must now find what is called the transpose of this, which is the adjoint. The transpose of the cofactor matrix is what is called the adjoint. So the adjoint now is this. The adjoint now is C this. So what will be the adjoint of this? we know it will simply be what? You take this, what was the elements of the first row? It will be the elements of the first column. What was the elements in the second row? It will not be the elements in the second column. Then this is the adjoint. That's right. Then from the next, how to find the inverse now? We know that the inverse now of A. Therefore, the inverse of A now, it must now be what? The product of this and the determinant, not the determinant, but the reciprocal of the determinant. Therefore, it will be 1 over minus 5, then multiplied by this, which is how much? Minus 3, minus 2, minus 1, and 1. Then that is the inverse. And therefore, what is x now? Remember, x here is the inverse multiplied by b. It will be this. And now, what is the inverse? The inverse is this. Then the inverse is minus 1 over 5 multiplied by this. Hopefully you can still see. Then it will be multiplied by b. Multiplied by b. What is b? Is 3 and 4. Then from there you carry this. Don't forget what is x. This is the matrices, the matrix of the unknown. That is x here is x and y. Then you just have to multiply this. You can just simply keep this out for a while, just for now, and multiply these two. Just keep this for a while and multiply these two. What is the answer here? Multiply these two. It will be minus 3 multiplied by this, which is minus 9 plus minus 8. And what is minus 9 minus 8? It's minus 7. Therefore, this it will be, let me see whether we cannot squeeze it here. Squeeze it here, yes. It will now be minus 17. It's good. And what about this? Multiplied by this, it will be negative 1 multiplied by 3 plus 1 multiplied by 4, which is 1. It will be negative 1 multiplied by 3 is minus 3 plus 1 multiplied by 4, which is 4, minus 3 plus 4, it is 1. Then from there, now you multiply this now. If you multiply this now, hopefully you can still see. If you multiply this, it will just be simply minus 1 over 5 multiplied by 17, which will be, let's squeeze it here. Hopefully you can see. It will now be 17 over 5. What about this one? That is minus 1 over 5. I'm not sure whether you can see this. So therefore, the final answer here, it will not be, let us take this out. It is how much here? It is how much here? Minus 17 over 5. And what? And 1 over, is it minus? No. This is 17 over 5. This is minus. Meaning now, you can now conclude then. You can now conclude. Because we are saying these two matrices are equal. Therefore, this element here, x, it must be equal to this. Therefore, x must be equal to 17 over 5. Then what about y? Y must now be equal to this. Then therefore, y must be minus 1 over 5. We have used the matrices. You didn't solve this, simultaneously using that grade 12 syllabus or using Grammar's rule. You have solved it using matrices. Any question, you have solved it using matrices. So if you still have time, what do? Replace them. We know how to check. How do you validate? You replace X by this here. You place X by 17 over 5 here. Then you replace Y by minus 1 over 5 here and see whether the answer it will be 3. If it is not 3, then you know you are wrong. No argument. If you replace X by 17 over 5 here and replace Y here by minus 1 over 5, the answer must be 3. The same story with replacing X here by 7 over 5 and replacing Y here by minus 1 over 5. The answer must be 4. If the answer is not 4, then you know you are wrong. Then you go back and check. Something went wrong here. You go back and check. Any question? Nothing. But when I'm checking here, but did I write it is, oh, okay, I wrote something else. I didn't write what I have, what I initially thought here. No. There's no problem. But no, man. Okay, no. I didn't write exactly what I had here. Is everything here correct? Yes. Okay, if you want to check, let's check. Let's quickly check. Let us quickly check. If X is 17 over 5, this will be 17 over 5. Let us quickly check. Let us just use your calculator. Use your calculator to check this. What is X? It's 17 over 5. I'm quickly doing it. 17 divided by 5. Then plus what? Plus 2 multiplied by what? Multiplied by negative 1 over 5. Let's see. Let's see. Is it correct?
Yeah, I get 3.
Yeah, that's right. It's correct. It's correct. You can do the same thing with equation number 2. It will still give you the same. It will give you the, it must satisfy equation number 2 as well. But you can still now go and check because it must satisfy both two equations because you are saying now the point 17 over 5 and minus 1 over 5, that is where these two intersect. Meaning this point must satisfy both the two equations because this point now is on the graph of those two equations. That's good. So if you understand it, then we can just look at, let's say, the last example, say a 3 by 3. Because it was 2 equations, 2 unknowns. What about if it is 3 equations, 3 unknowns? It can even be what? 4 equations, 4 unknowns. The procedure is the same. The procedure is the same. So let us, I looked at one of your example there in the study guide. I noticed something they made a mistake somewhere. So let us do it because I saw a mistake somewhere. Then I said, it's better than use it as an example. And that will help you to correct it. I can't remember which example was it, but it is there in your book. I'm writing it here. It's there in your notes or your book. I think I noticed a mistake somewhere. That's right. They say solve this very specific using matrices. But if the question is just open, say solve, then you can use any method. But if it is specified a method, then you cannot choose. You can't choose. Using matrices. So what do? Check first whether your linear system is in standard form. Is it in standard form? Check first whether it's in standard form. Is it in standard form? All the x, they are the first terms. What about the y's? They are the second terms. So what about the z? They are the third terms. Are all the constants isolated on the right side? Yes. Therefore, this is in standard form. Then what do? Then construct that coefficient matrix. Coefficient matrix, we call it A. How do you construct it? You are using the coefficients, because that is why it's called coefficients matrix, meaning the coefficients of your unknowns. Then it will be, what is this? This is 1x, and then you just write 1. What is this? This is plus 3y, then we just write 3 without the variable. What about this? It's 2z, then we just write 2. Then from there here, what is the numerical coefficient here? We know it will be 0 because it's 0x. We don't have to write it. What about here? You say 4. What about here? 1. What about here? 3. What about here? 7. What about here? 6. Then this is what is called the coefficient matrix. Then from there, what next now? Because in matrices, we are going to use the inverse. So does it have any inverse? You check, you use what? The determinant. So what is the determinant of A? The one that will tell us whether this is singular or non-singular. So you can use any method to find the determinant here. You can expand along any row or along any column or use serifs. So with expansion, we've said preferably use a row or a column that has got 0 entries. Which column or which row has got 0 entries? The first row, does it have any 0 here? No. What about the second row? Yes, there is. What about the third 0? No. What about the third row? No 0. What about the first column? There is a 0 here, 1. Here, none. Here, none. Therefore, what? You better expand using the first column or the second row. It will halve your work. Either use the first column or the second row. That is, either use this or you use this. Don't forget, the determinant is unique. It doesn't matter which row or which column you have used. So let us just agree. Let us use the first row. No, the first column. Let us use the first column. Finding the determinant. So it will now be what? You write this element. We know it. It will be plus 1. Then you cover both the first column and the first row. So what will be the answer? Then you find the determinant of whatever is left. So whatever is left, it will be what? 24 minus 7. It will be 24 minus 7. It will now be 6 by 4 is 24 minus 7. So it will now be, what is 24 minus 7? It is 17. 24 minus 7 is 17. We don't even have to talk about it. This one multiplied by 0, because at the end it will be 0. So it will not be what? We can just skip that. It will be plus. Plus what? Now this is going to be positive. It will now be 3 in brackets what? But please make sure that you are not left behind. Now you cover, because it's in the first column, you cover the first column, then you cover the third row. Then you take the determinant of whatever is left, which will be 3 minus 8. And what is 3 minus 8? 3 minus 8 is minus 5. Then this, it will be minus 5. Then you write the answer. It will be 17 minus 15. What is 17 minus 15? It is 2. 17 minus 15 is 2. Therefore what? Therefore, this now has an inverse. Therefore, we can proceed. Then how do you find the inverse? We know it. We must first find what? Remember, this is the coefficient matrix. Then we must now find the cofactor matrix. This is the coefficient. That we must now go and find what? The cofactor matrix. How do you go using the cofactor matrix? You must now find what? The minor. How do you find the minor here? The same story. You are going to cover the first row, the first column, the first row, the first column. You get their determinant. So it will be 24 minus 7, which is still what? 17. Now what about M12? M12, you cover the first row, the second column. That is the first row, the second column. Now you have got what? 0 multiplied by 6 minus 3 multiplied by 1. So which will be minus 3. Now what about M13? Please make sure that you are not left behind. So you cover both the first row and the third column. The first row and the third column. It will be this. The first row. And then will be how much? It will be 0 multiplied by 7 minus 3 multiplied by 4, which will be how much here? Which will be minus 12. Which will be minus 12. Then from there it will now be what? M21. What? M22. What? M23. Then from there it will now be M31. What? M32. What? M33. Then from there what? Get the coefficient matrix now. Not the coefficient man, the cofactor matrix. So what is M21? Let's tell us the answer now. What is M21? Anybody tell us what is M21? M21. Anybody? You can say you don't know.
3276.
Just tell me the final answer. What is the final answer? M21? Nobody will say, I don't know. We all know.
I think it's 4.
It's 4. You say the answer is 4.
3 times 6 minus 7 times 2.
Final answer? Are you still there? The others? Then if you cannot give us this one, then it means you are not with us here. So what is M21? You cover the second row.
Yeah, I get 4.
And which column? Then you cover the second column. Then you will be left with what? 3276 here. If you cover this, you are now left with 3276. Then you find its determinant. Therefore, it will be 18 minus 14. What is 18 minus 14? It's 4. 18 minus 14. You can't say, where's a calculator? 18 minus 14 is 4. Then what about M22? You cover both the second row and the second column. You will be now left with what? 1, 2, 3, 6. 1,
Zero.
2, 3, 6, because we have covered this. It will be 1, 2, 3, 6. And it will not be what? 6 minus 6. So which is how much? 0. What about M23? M23, you cover the second row, the third column. That is the second row and the third column. You cover this. We're now left with what? 1 here, 3 here, 3 here, 7 here. It will now be 7 minus 9. What is 7 minus 9? 7 minus 9 is minus 2. You can say, where's my calculator? So what about this one? M31. What is M31? You cover the third row, the first column. You cover this. So you are left with 3, 2, 4, 1. Meaning it will be 3 minus 8. What is 3 minus 8? It's minus 5 because it's 3 minus 8. Then from there it will be M32. You cover this, you cover this. So it will not be what? It will be 1 minus 0. It will be 1. Then from there, what about M33? You cover this, you cover this. So it will be 4 minus 0, which is 4. It will be 4. It will be 4. Please don't tell us that you are not with us. That is good. Then it will be this. And from this now, we need to construct what? That cofactor matrix. We need to construct that cofactor matrix now. We can take this out because we do. Are we still going to need this? No. We can just take it out. We can now squeeze the cofactor matrix here. Cofactor matrix. Let us call it C, the cofactor matrix. So what will be this? The cofactor matrix. This will give you what? The elements of the first row. But don't forget their sign factor. It will be the elements of the first row. This will give you the elements of the second row. But don't forget the sign factor. This will give you what? The elements of the third row. But please don't forget the sign factor. Now, when you edit these two, this subscript, 1 plus 1 is even. Therefore, this we're going to multiply it by positive. Therefore, it will be 17 here. What about this one? Edit 1 and 2 is odd because it's 3. 1 plus 2 is 3. It's odd. Therefore, this we are going to multiply by negative. So then it will be 3 here. What about this one? It will be 1 plus 3 is even. Therefore, we are going to multiply this by positive. Then it will be this. What about this? It's odd. Therefore, you're going to multiply it by this. What about this? Doesn't matter. What about this? It's 2. It will be this. Then from there, what it is? The sum here is even. Therefore, you're going to multiply it by positive. It will be this. The sum here is odd. You're going to multiply it by even. Odd. No, you multiply it by minus. It will be this. This is even. You're going to, then it will be this. Then this is the cofactor matrix. Cofactor matrix. Then we can take them out. This is the cofactor matrix. Cofactor matrix. Then now, next now, what do? You must now find the adjoint now. What is the adjoint? Is the transpose of this. The adjoint is the transpose of this. Then we must now find the adjoint, which is the transpose of the cofactor matrix, which is how much now? We just have to find out the transpose now. How do you find the transpose? What was the first row? That is the elements in the first row will now be the elements in the first column. The elements of the second row will now become the elements of the second column. The elements of the third row will now become the elements of the third column. That's good. Then it means 17.3 minus 12 will now be here. Minus 402 will now be the second row, not the second column. Minus 1, minus 5, minus 1, minus 4 will now be the elements of the third column. Then it will now be 17 here, 3 here, minus 12. That is this. With the transpose, it will not be this. What about this? It will not be minus 4, what? 0 here, what? 2 here, what? Minus 5 here, what? Minus 1 here, and 4. This is now the adjoint. And I think the mistake that I saw there in your study guide, they said this is 9. They said this is, no, not 9, 19. Yes, I remember. They said this is 19. It's not 19, it's 7. They said this is 19. It's not 19, it is 7. I'm not sure whether they have corrected it already because I'm using last year study guide. So then, now what is the inverse now of A? The inverse of A, we know it will not be 1 over the determinant multiplied by the adjoint, which is this. Hopefully you can still see. If not, you tell me. It will be this. That's right. Then that is the inverse. That's right now. Therefore, what is X now? Therefore, X now, don't forget, X is how much here? X. Let me just write it here. X here is inverse multiplied by B. X is this. And here, what is, let us just squeeze it this side, then let us squeeze it this side. That is this. We are saying X, meaning our unknowns here. Let's decide what is X. X here is our unknowns, is X, Y, Z. It will be this. It's equal to this, which is this. Hopefully it makes sense. Then multiply by B. And what is B? Is the coefficient formed from the constants. So what is B now? B in our case is 2, 3, 1. B is this. Now from there you multiply this. You multiply this, then you get the answer. You can just simply keep the half outside for a while. Keep the half outside for a while. Simply say half. What then? Half what? Because it will now be 17 multiplied by 2 is 34. You can just simply use a calculator. Let us just simply use a calculator. You just simply open brackets. You say 17 multiplied by 2. Then you close brackets. Then it will now be what? Plus what? Plus this multiplied by this. That is minus 4 multiplied by 3. Because obviously you're going to say plus and then open another brackets. I've opened the brackets. How do I go back? What is the answer? It would not be negative 4 multiplied by 3. Hopefully we are doing it together. Then outside, then you say plus, you open another bracket. It will be negative 5 multiplied by 1, which is just negative 5. Close brackets. What is the answer? The answer is 17. 17 here. Now, what about the next one? Don't forget the next one, it will not be what? It will not be this multiplied by this. where it will now be 3 multiplied by 2. This one doesn't need a calculator. 3 multiplied by 2 is 6. Plus, this is 0. This is minus 1. Therefore, it will be 6 minus 1. What is 6 minus 1? You can't say you are using a calculator, Brenda. 6 minus 1. 6 minus 1 is 5. 6 minus 1 is 5. Now, what about the next one? You can't even say you are using a calculator because it will just be what? Negative 12 multiplied by this is minus 24 plus 6 plus 4. It will be minus 12 multiplied by 2 is negative 24. This and this is 6. This and this is 4. We know this is how much here. This is 10. And this 2 is how much? This 2 is minus 14. Then from there, you multiply each now inside by half. Therefore, this, it will be 17. This, it will be 5 over 2. And this, it will be minus 7. Because it will be half multiplied by 17 over 2, which is 17 over 2. It will now be half multiplied by 5, which is 5 over 2. Then it will be half multiplied by minus 14, which will be minus 7. Therefore, at the end, we can just simply erase this. Therefore, at the end here, it will now be 17 over 2, what? 5 over 2, what? Minus 7. It will be this. Then from there, you conclude. Therefore, you conclude then. You conclude. What is x? X is 17 over 2. And what is y? Y is 5 over 2. And what is z? Z is equal to minus 7. Then you know you have solutions. But before you submit, if you still have time, meaning you must be quick, so that you will have that time for just for checking. Then from there you come and substitute in here. You say x is 17 over 2. Then you replace x here by 17 over 2. Then you say plus 3 multiplied by y. What is y? You replace y by 5 over 2. Plus 2 multiplied by z. What is z? Z is minus 7. And see whether the answer is 2. Or you can even use it this one. Because this one has got only 2 terms. You say 4 multiplied by y. It will be 4 multiplied by y. Y is 5 over 2. Meaning it will be 20 over 2, which is 10. Then plus z. Z is minus 7. Therefore, it will be 10 minus 7. What is 10 minus 7? No calculator, we know it's 3. Then what we know, we are covered. If it is 3 marks, then you know you have got 3 marks for this. If it is 1 mark, you have 1 mark for this. It doesn't matter which marks is it, as long as you have it in your pocket. Most importantly, in your back pocket, the one with a zip, then you zip it. Then you know you are covered. Any question? I don't have anything. I don't have anything. I think that these 2 examples, I think they are enough. Any question? Any question? Helen put us on hold. Any question? Any question? Do you have a question, Brenda? 3, 2, 1, gone. Maybe
No.
Brenda is not even around. Any question, Tulari? Do you have a question? 3, 2, 1, gone. Mabuja, do you have a question today? 3, 2,
No, thank you, sir.
1, good. Tulari, a question? 3, 2, 1, Quinton, a question? 3,
No, thank you.
2,
It's clear, sir.
1, Marilana, do you have a question today? I don't remember you asking me, Marilana. Do you have a question today? Is it the last session? We've said this is the last session. But this is the last online session. If you still have any question, yeah, you can please email it to me. Okay, just simply post it in that forum. but in the forum, it may take me 3 or 2 to 4 days without even seeing it. So if you email it straight to me, then, you know, then I'll be able to see it the very same day. Otherwise, if you post it in the forum, how many times do I log in the forum? Maybe just once a week or twice a week. Otherwise, no. If nothing, then hopefully we will see each other before your exam. Otherwise, good luck. I enjoyed teaching you. And then good luck with your exams. But hopefully, we will talk before the exam. When is the exam?
We still don't know. That was one of the things I'm hoping you knew.
No, I don't. Remember, I'm
Okay.
not your lecturer.
Under
18.
my UNISA app, it says 13 October.
18 October.
Sorry, where does it say it?
Yes.
18, 1 3.
Yeah, 13 October at
Yeah,
1
then,
p.m. I think.
yeah, then it means you still have got what? More than a month. And hopefully you will ask me something before the exam. Any question before we close this session? Because I think the rest, I think is just, yeah, you can do it on your own. The rest, you can do it on your own. Okay, if nothing, then Brenda, don't forget to switch off, ne? To stop
Okay.
recording.
Okay.
Yeah, otherwise, because somebody's put us on hold here, then it means it will just go on and on and on and on. Thank you very much, dear, and